it could be confusing, mainly because this topic in Form 2 is an extension of Form 1 work, but we are going deeper. And the depth that we're going into is basically writing of equations. You're continue, for example, assets basis. The definition in Form 1 was basically the welcoming type, ile ya kukaribisha wanafunzi. So it is very easy. Now, when you go to Form 2, the definition that is in Form 2, we normally go, we step a little bit higher, and then we give you the actual definition that you will do, you will use all through up to the time you sit for the exams. So it is very important. Now, let me try and share my screen so that we can start that topic. Hopefully, very quickly. Okay, first of all, let me search for that and then I'll be back. But in the meantime, can you tell me, by the way, what you learned about acids, bases, and salts? Maybe the previous lessons as I go for my notes. So I can mute myself.
We learned about balancing the equations, symbols, yeah, naming the salts and symbols and balancing the equations.
There's no problem. I'm going to share the screen. So I was searching for the notes so that it becomes very easy. So if you did the balancing of the equations, I think balancing of the equations, basically we are going to deal about that one more. Again, we are going to balance equations. We're going to write the reactions that occur. Do this very quickly. The reactions that occur when you hit salts. So basically we are going to do the same thing, but now we're going to go deeper. We're going to go deeper because of if you know how to write, did you do the word and the, is it the word equations? I wanted to know if you did the word equations and the chemical equations, writing of the chemical equations. You know, we have the word equations and the chemical equations. I don't know if you discussed that one. You can also say something on that.
Yes, we discussed and we did some. We tried to answer together with the teacher.
Okay.
And the teacher took us through also in how to know the solubility, the key ones.
Okay.
The salts that are soluble, the ones that are insoluble.
Okay. So I think basically you almost did what you're supposed to do. But anyway, there's no problem. We are going to see, because I don't think you were told, did you touch the meaning of salts, the types of salts, the solubility of salts? I don't know if you touched on that.
No.
Okay, then we are okay now. So this one, you can see the screen.
Yes, I can.
Okay, so that one is chapter 4. Now, I was being told by the teachers that they decided to combine, to do topics that are related from Form 1 to Form 4. So if you have done acids, bases, and salts in Form 1, we go to Form 2, and then we do the Form 4, because you have another topic in Form 2, Form 4 that is touching on the same topic, which is acids, bases, and salts. So this one is now a Form 2 chapter. It is chapter 4 in Form 2. So they're saying it is better for us to do, because we are special candidates. it is better for us to do something that is related from Form 1 to Form 4. And then when we come to another topic, for example, organic chem, we do organic chem from all the way, Form 2 all the way to Form 4. That way, I think it will be easy to understand that way. Now, so in this topic, we have, I'll give you, these ones are the major. Now, we are going to discuss what, we are going to see what we're going to discuss one by one. For example, I don't know, but I think the notes will be shared. Yeah, I think the notes will be shared. I still can send the same notes later on and some questions to follow up. So these are the things that we're going to discuss in this topic. In this topic, we have very many things that we're going to touch on, but the main one that we're going to touch on, we are going to. So number one, we are going to define the source, because it is very important for you to define the source. The definition that we're going to give, mark me very well. This definition is the one that you will use up to the KCSE time. The definition that is in the KLB might not really be the same with the one, because now the definition of source previously, when we were teaching students, we used to find that the definition is from 1 is something different. The definition is from 2 is something different. The definition is from 4, which was actually what we're going to use all through, is something different. So we decided to, why don't we use the from 4 one for the division of all the classes? And the definition that we are going to give will be that one, that will be used. So the next time that we meet, or you meet in another class, the definition that will be given by the teacher in Form 4 now, which is in assets, bases, and source, will be the one that I'm going to give today. So it is very important for you to capture this one, because now source, I don't know if you are set for your exam, but source must always be there in an exam. Always be sure of that. Now, number 2, we are going to do the types of source. Types of source is very important. It is very important. You must know the definition of maybe the normal source. And I normally say when I teach my students, at least I have an example. There was a case this year, I don't know if it was 2023 or 24. They were asked with the examples. Well, now, something that comes with the examples, define or differentiate normals and acid source. So you should have at least 2. I normally tell people to have at least 2 examples, so they don't talk about that one. Now, solubility of salts in water. This one, we will only talk about those ones that have been mentioned. We have sulfates, chlorides, nitrates, and carbon. It is very easy to manipulate this one or to work with this one. It is very easy for you to remember this one. So we'll talk about that one. Now, in Form 4, let me just touch a little bit of it. In Form 4, the solubility of salts now will be doing the graphical solubility. You actually tell me the solubility of, for example, specific salts now, potassium nitrate, at a certain temperature, which you will see about that. So the only thing, the solubility of salts in water in Form 2 basically touches, we are going to touch on cumulative names. For example, how does sulfate dissolve? And then how does nitrate dissolve? But in Form 4, we go to specific source. How do potassium sulfate, for example, how do sodium sulfate dissolve in water? And in Form 4, we change a little bit of the word. So it is solubility of in 100 grams. So we'll be using now an actual value of volume of water or weight of water or mass of water, depending. So it is the same thing. Now, and then because now also bases are salts. Actually, they are salts, but basic salts. So I don't know if you talked about basic salts. So we love solubility of bases in water. We'll touch a little bit of that again. And then number 5 is something that is always done in Form 1. So it is interesting that it is here, but it should be a division of obtaining of crystals. I am very sure that somebody knows about obtaining crystals in separation of mixtures or something. I'm very sure that you are aware of that one. Separation of mixtures, that one is something in Form 1. It is a topic in Form 1, separations. Now, and then of course, a very crucial topic again that normally comes in, and this one must be tested always. Preparation of salts. Preparation of salts. Preparation of salts tulifanya, we have done in various classes also. I think it was also in Form 1. I think there was a place that in preparation of salts in Form 1, we are talking about separation of substances. So I think separation of substances, part of it was actually preparation of salts. Lakini hatukuambiwa. I'm seeing somebody in. Welcome, Mr. Rotich. I don't know. Mr. Rotich, you're coming for the class. It is chemistry. Are you okay? Can you hear me and can you see the screen? I don't know. Let me just check. I think somebody said something. Okay, no problem. I don't know. I'm asking if Mr. Rotich, you
Teacher,
can hear me. Yes.
I think you have just put the topics on the screen.
Yes.
Okay.
Yes. Yeah. I was, but you can hear what I'm saying, Mahura.
Yeah, I can hear you very well.
Now, there's somebody who joined. You can see Mr. Rotich.
Yeah, he's there.
I was asking if you can see the screen because sometimes we have a problem of okay, join, you find the screen is blur.
I think ataparticipate, ataongea akisettle.
Oh, okay, then no problem. Then we can continue. So we have solubility. So we are talking about preparation of salts. So in preparation of salts, we have the insoluble salts. How we prepare the insoluble salts? We have the soluble salts. Now we have the special salts. As you can see, even in the solubility, we have three special salts, which is sodium, potassium, and ammonium salts. So those ones are also very, very crucial salts. They have different characteristics than the rest. So you'll find we'll be talking about the rest, and then we say hawa watatu sasa, the sodium, potassium, and ammonium salts have a different characteristics than the rest. Hope that one is okay. So we have acid-base reactions. That one was done again in Form 1. I think this one is where you did the reactions in Form 1. Where you were writing equations, this one is how you did it. Now, acid-base reactions, and of course, for when we are introducing this topic, basically we normally say it is neutralization. Acid-base reaction, by the way, is normally neutralization. Neutralization reaction, I think you must have mentioned somewhere in Form 1 when you're doing that one, where you said a process where I think that is where you are defining an acid some times back. I think you defined an acid and you said it's something that reacts with the base to form a salt and water only as the only product. That one actually is the neutralization reaction. But that one is not basically the definition of a salt. But we'll see about that one. And then, so we continue. We'll talk about the uses of salts. First, uses of salts. Some of them you're already familiar with. For example, food additive, hiyo ya nyumbani. So uses of salts, they're not really a tough one, because you already have one. We'll talk about another one. Of course, I think in Form 1 also we normally say it is normally, for those, I don't know if you are doing physics. For those of you are doing physics, you normally say sodium chloride is normally used in defrosting of roads in the Europe countries. So that one, but those ones are basically the uses. The uses is daily things that we see manene salt. And then of course a very, very important part of this one, which was there in the KCSE last year. It was there in the KCSE last year. This one. Because I had Fununu, somebody told me. Action of it on
Copper sulfate.
yes,
It was
it is
copper sulfate.
very dangerous. Yeah, I'm very sure it never misses in an exam. Special case. Action of it on salt, very dangerous. We'll talk about that one. And of course, the action of it on salts are normally different. So it will be there. I'm very sure it will be there. No. Just have a brief about now introducing this salt. Now I'll be writing some of the things that maybe the questions we can do it hapo kando. But the good thing now is I'm teaching people who already know about how to write ionic equations, how to write equations. Of course, I'll be touching on the same things again, but now most of the time, my writing will not be, we are writing the name of the salt. We'll be writing actually the chemical formula of that salt or of that thing that we are going to handle. I normally say in chemistry, it is better. It is way much better to know how to write the chemical formula rather than its name. The chemical formula will help you in other places. Of course, when you're writing the ions that are present, it will help you. So it is better for us to write, for example, we'll see as we continue. So number one is the definition. How do we define a salt? So we say a salt is a product or is a substance formed. Now, I will give let me just read the one that you can see on the wall, and then I can give another one. So is the substance formed when hydrogen ions. This one is hydrogen ion. I think when you scan this one, there was a problem. Is when hydrogen ions in an acid are fully, which is wholly or partially replaced by a positive ion. We'll talk about the positive ion in the equations below. Now, in form, I don't know if this one is in form. I think this one is in form 1. Basicity of an acid. We normally talk about basicity of an acid. The good thing about talking about basicity of an acid as early as now is it will be there in acids, bases, and salts again in form 4. So basicity of an acid, we normally say, is the number of hydrogen ions that are present in that acid. For example, so when this one, let me write, now, so these ones are the ions. So these ions. Now, the replaceable hydrogen ion is called basicity. Basicity of an acid. We have now different acids. We have the monobasic acids. We have the dibasic acid. We have the tribasic acid. It is very important for you to capture this one because it will be there in the next session, which is the form 4 chapter. So when we talk about monobasic acid, ni ile acid iko na only one replaceable hydrogen ion. For example, a very good example, which is normally the easiest, one of the simplest acid that we have is this one. So when you remove this one is hydrochloric acid or hydrogen chloride, depending. But we normally call it hydrochloric acid from the market when it comes to the market, but it is hydrogen chloride. It's a combination of hydrogen and chlorine. Of course, this one is one of the acids that can be prepared by direct synthesis. We'll talk about direct synthesis later on. Iko huko mbele. So, and if I'm moving too fast, please unaniambia. I have a tendency of speaking very quickly. So, unaniambia, I tone down. Now, so we were talking about now the basicity. So a salt is a substance formed when hydrogen ions of an acid is partially or fully. All means fully, removing all of it, or partially replaced by a positive ion. Now, for example, when we have sodium, I don't even want to use the example below. Tukae tu kwa monobasic first. So we have hydrogen chloride.
Teacher,
Is it
please.
okay? Yes.
Kuna kitu hatuoni kitu ingine kwa nini kwa board? Ni ile tu ulikuwa umeandika ile ulikuwa display topics pekee.
Oh, you have not seen the lower part? Can you see the definition of terms? Kidogo?
No.
Let me.
Yeah,
that is. Oh, I've moved to the second page. Can you see the second page now?
No.
Yeah. That is okay. Let me stop sharing and then I reshare. Is that okay?
Okay.
I think it will help us. That is one of the problems we have. That is, I was telling you, ukitoka na uingie, you find problem. How is it now?
Iko sawa sasa. It's okay.
Iko sawa.
Yeah, we can see it, yeah.
Yeah. So yeah, that is the problem of these things. I was continuing because you could see, so they may scroll to chini and it disappears. That is the only problem that we have with technology, but it is okay. So now, a salt actually is a substance formed when hydrogen ions in an acid are only fully. I'm saying this one also means This one, wholly, means full, fully. So ama the word wholly imepotea, all of it, the whole of it imepotea, you can write fully. So this one is still correct. So when you replace fully or partially, when you replace fully or partially replaced by a positive ion. Now, in an acid, the replaceable hydrogen ions are normally called the basicity of the acid. The basicity of an acid is actually replaceable hydrogen ions. The more the hydrogen ions, the name will be changing. For example, when you have one hydrogen, replaceable hydrogen ion, for example, in HCl, which is hydrochloric acid, we have nitric acid, we have the carbonic, most of the carbonic acids actually have that one. So this one is methanoic, this one is ethanoic. So most of the carbonic acids have actually one replaceable hydrogen ion. So that one is very important for us to know. Yeah. So methanoic acid is this one. In methanoic, this one is ethanoic, those ones. Actually, zenye zinapata the organic chemistry, organic chem 1. So that one will be there. So when you have one replaceable hydrogen ion, we say that one is monobasic. That means the basicity of that acid is 1. That means one hydrogen, for example, that is what I was writing now. I'm very sorry, I was writing the equation. So for example, we have HCl. So H actually is the positive ion, which is now the replaceable hydrogen ion, plus the chloride ions, which are negative. I'm writing for the sake of understanding. So this one, we say that one is monobasic because it is 1. When it is replaced by another positive ion, for example, so nitoe hii kwa HCl na niweke sodium, which is positive sodium. I'm very sorry because I'm using a old school laptop, so kuandika I have to use the cursor. So when you remove the hydrogen ion, now wake a sodium ion in that acid. So that means you have replaced a monobasic. We have replaced a basicity of 1 na tuweke sodium. The outcome now, when you add the two, unapata, you get sodium. Sorry, let me just write this one in. I'll not do the rest. I wanted to do this one for understand. You get sodium chloride. Now, when you remove the hydrogen, which is this, and then you add another positive ion, which is this one, which means it was in another salt. We could be reacting salt and an acid. So what you get now, this one, after we have replaced that one, the hydrogen ions with another positive ion, whatever you get is a salt. Sijui kama tuko sawa mpaka hapo, so that I can wrap this one. Are you okay mpaka hapo? So that when I'll be touching the second one, I don't have to touch the. If you're okay, we continue. I hope you have understood that one because that is actually what we'll be writing. That is why I had to do it literally. Hope you're okay. Now, that is when you have. This is when you have now a monobasic acid. The basicity is 1. Now, when you have basicity of 2, we normally call those one dibasic acid. Let me press this one very quickly. Of course, before I finish, I'll still define for you. I still define the other definition of acid. I'll still give you the other definition of the acid. Now, when you talk about dibasic acids, they mean they have two. A very good example is sulfuric acid. Sulfuric acid, we have sulfurous acid. Sulfurous acid, those ones are very important. Those ones have two. As you can see, it is very clear from the. It is very clear from. Actually, it is very clear from. Let me reduce this one. It is very clear from the formula. So it is very important to write the formula correctly. So dibasic acids, they have two. We have tribasic acids, they have 3 hydrogens. So for example, if I was to write this one in the chemical formula, breaking, of course, those things, I'll write this one. So you'll find that it is hydrogen ions, which is, but they must be 3 because now of the in tatu plus. I don't know if that one is visible, or I can add the other one, but I think it is. I don't know if it is visible. Make sure that you can see. And then we have phosphate, which is normally phosphorus. From phosphorus, so we have the phosphate, which is PO4, but now it is 3 negative. So when you combine these two, you get actually phosphorus or phosphoric 5 acid. Yeah, phosphoric 5 acid. So that one is very important. Those ones are what we do now. Tuko sawa mpaka hapo? So that one is tribasic acid. We have other acids that have bigger values. But for the sake of the 844 system, we study only the 3. We have the monobasic, the dibasic, and tribasic. The monobasic 1, di 2, tri 3. That is actually how it is done. Now we continue. The types of salts. So how salts are formed? Actually, I don't written for you the ionic equations. Hapa juu pale nilikuwa naandika sodium replacing the hydrogen. So we have the ionic equations. We'll talk about that one down. So what this person has written, you see this one now, the example that you have been given. The example that you have been given, this one is sodium hydroxide, which is actually a base, plus the sulfuric acid, which is the acid, gives us a salt. So this one is the salt, yenye nimesakol ni salt plus water. Equation, this one is the equation that we call neutralization equation. I know you mentioned it in Form 1. Somewhere, you must have mentioned neutralization. If you didn't mention, I think it will be mentioned again. In Form 1, we must talk about neutralization reaction. A reaction where we are combining, let me just write a base. B is for the base. We have the acid to give us salt. So this one is the salt, the one that we are talking about now. The one that I've circled is very important because it is the topic that we are touching now. So we have base, which is A. B is the B is for base plus the A, which is acid, gives us a salt, which I've said this one is S. This one is the most important part of it because it is actually our topic. So it gives us the salt, and then the W is the water. That one is this one is this equation is the simplest equation that we have in chemistry, which normally is called, we normally define a base in Form 1 using this formula or using this chemical formula that we have written. This chemical reaction that we have written, where we have sodium hydroxide plus sulfuric acid gives us sodium sulfate and water, is an equation that we normally write, or we normally use it as a method of defining salts in Form 1. Iko sawa mpaka hapo? So that one is, so this one is the neutralization. It is very important for you to know, I don't know about neutralization. Yeah. You can just finish neutralization reaction. So that one is the neutralization reaction. Now, after that, we know what a salt is. So I'd said I would give another definition of the salt. But this one is the correct definition. The other definition is we're just manipulating the English kidogo, but it is the same thing. So for example, you know, a salt is a product form, is a product of hydrogen ions in an acid, partially or fully replaced by a positive ion. As you can see, I want you to see from that definition now, I want you to see something, and then we move very fast. We are just seeing something. Now, let me just wrap all of this first, and then I show you from this equation what I'm talking about. And I hope you're understanding. If I'm moving too fast, tomorrow you tell me. So, this one, I want you to see this one. This one is actually the positive ion in the positive upper. EOH in the negative. Upper hydrogen is positive, and then the sulfate is negative. So when I remove this one, the one that I've cancelled, and then I bring this one out to replace that one. Whatever is formed after I've deleted or nimesukuma hydrogen from the sulfate, and I take over the sulfate, that one is the salt. I told the from 4th of last year, the students I was teaching, actually, what is happening? I think I can use this one. I don't know. I withdraw the statement if it tells anybody. The sulfate is divorcing hydrogen and taking a new husband or taking a new wife. That is what I normally tell them. I think the students normally understand better when I say that. I don't know. They will never forget that one. They can forget when they are replacing hydrogen ions, but they never forget divorcing. So they can write, actually, they wrote the correct answer because of the divorce part of it. I don't know. So hydrogen is being pushed out, and then now taking somebody else in. I think that one is better. And then whatever now, when you take somebody else in, after removing the hydrogen from the from the equation, you get the salt. So whatever is formed is a salt. Now, hapo sawa? I hope I'm not moving very fast. Types of salts. We have 4 major types of salts, and the names are very easy. These ones are very easy. There's a method that we normally use to remember these ones. So in case imekata tena uone, so we have 4 major types of salts. That is according to 844 system. Of course, when you continue, we'll add other salts. Yeah? If you continue with chemistry to other levels, we'll add other salts. So the types of salts that exist now, so far, in 844. And the good thing about chemistry, I normally tell students, everything changes with the time. So there are new developments, there are new inventions. So of course, types of salts. Number 1, normal salts. Number 2, acid salts. It is very important for you to remember the. I don't know if you were told the denotation of an acid. I'll still give you the how we normally represent an acid, basically, and how we represent a base. Now, number 3 is basic salts, and these things have been arranged in such a way that normal salts are the same place, and then you go now to the double salts, which are a little bit complicated. Sorry. So we have normal salts, we have the acid salts, we have the basic salts, and we have the double salts. The double salts are normally a little bit complicated. We'll talk about that one. And we give another name. I normally give double salts another name. But before we give it another name, let us go to the double salts. So, normal salts. So, normal salts, they do not contain, these are salts that do not contain any replaceable hydrogen atom. They do not, what I'm talking about is they do not have an hydrogen in their chemical formula or in the chemical writing. Anytime you write that one and they do not have an hydrogen, and then you say that one is a normal salt. And I said it is very good to have at least 2 examples. The examples that I still give up to date to my students is sodium chloride. I think that one is the simplest one. It is the simplest one. So sodium chloride. Sodium chloride is number 1. This one is sodium chloride. This one is potassium sulfate. It is very important for you to understand how this one comes to be. Before even I continue, let me just ask: did you write how ions, how salts are formed in Form 1? Did you write the equation, the chemical equation itself, not the word equation? Please, Maura, did you write the equation very quickly so that I know I can handle this one?
Yeah.
So
Yes.
you already know how the sulfate is and how the chlorides are.
Yeah.
Is that okay? Okay,
Mm.
so it will be easy for me now. So we have sodium chloride, potassium sulfate, sodium carbonate, calcium nitrate. We have a lot of these ones. Of course, when you're writing these ones, when you're writing examples, write the examples that at least you have an idea of. Because we have salts that fall under this category that do not exist. We'll talk about those ones that do not exist, Cochin. So when you're writing about it, write those salts that you have ever heard of, or something that you went. I know you did practicals maybe sometimes back, kitu ulienda kwa prac na ukasikia iko. So actually in normal salts we have salts that do not exist. So it is very, very important not to write something that do not exist as your example. Yeah, hapo tuko sawa. So we continue, we go now to the acid salt. So these ones, what you're supposed to know is you should only know in the definition. Know the definition, and then you, after knowing the definition, you give at least 2 examples. Then I normally use the examples that mumesikia, they are mentioned a lot of times in class. I know one of the examples they normally say is, most of these ones are normally neutral, by the way. For example, the salt ya nyumbani, chumvi ile ya nyumbani, what we use as a food additive is sodium chloride, and it is neutral in nature. So they do not have actually any ions that can make it basic or acidic. We'll talk about that one. Now, acid salts is the next one. Acid salts, we normally say they have a replaceable hydrogen atom. Now, acids are normally written this way. If I wanted to talk about an acid without really mentioning an acid, I'll do this. Of course, you don't mind the handwriting. If I wanted to talk about an acid without mentioning the word acid, I'll just write H positive. H positive, we normally denote an acid as H positive. It is a denotation of, if I wanted to tell somebody this one is acidified, for example, acidified potassium manganate 7. What I can only do is, because I cannot write sulfuric acid at the same time the manganate 7. So I can just put at H positive to the acidified potassium, to the potassium manganate 7, and it gives me the H positive. Gives you the idea that it is acidified. I hope that one is okay. So we normally denote it by letter H. I will talk about the other one. Now, so it has acidic properties. That is what I was mentioning. So even the thing that has H in it, now there's a difference between H and OH. We'll talk about that one. Apochin. So we have examples, the sodium hydrogen carbonate. These ones are things that you are used to. We have the kind of potassium. And I'm saying, now let me just mention this one. When you're writing examples, especially for the first 2, I'll really advise students to go for the, what do you call, go for these salts that you have an idea of. For example, sodium inamenshoniwa mara mingi sana. We have potassium, it is mentioned a lot of times. So go for the 2. I would advise you to go for the 2. Go for the 2. Iko sawa mpaka hapo. So that one is the denotation of. Now we go to the basic salt. Now, bases are normally denoted by letter. So, for example, acid salt is H. Now, basic base or a base is normally denoted in the lab as. It is very important for you to note the, what they call, the ion charge, the charge of the ion. Okay, so I want you to see that the bases are negative. The bases are negative, the acids are positive. So it is very important for you to know that. So basic salts or bases are normally denoted by letter OH. Iko sawa? So basically the reason are salts that contain hydroxyl. Now there's another name for hydroxyl, which was old school, but it is now, it can be used. It is normally called hydroxide. It is normally hydroxide. You can say hydroxide pia or hydroxyl. Hydroxide or hydroxide ions. And this one they make the salts have basic properties. They make the salts have basic properties. A very good example. Now, when you are writing the chemical formula of that salt, it is written as magnesium hydroxide chloride. Yep. But when you are giving the name, actually, and I normally tell students, if, if, very important, if you don't know how to write the chemical formula, for example, of magnesium chloride, right? Unless it is stated in the question that you write the chemical equation, don't. Because chemical equations have very many issues. You can mess up. It has a lot of rules. So unless it is stated, just write the actual English name or the word name. For example, sodium chloride unaandika tu SODIM. Yeah, that one. If it is not stated, if it is stated now, that is where they will watakushika. But when it is not stated, you can write the English version of the name, which is sodium chloride. You forget about the chemical equation of the chemical equation of that chemical name of that particular source. So it contains hydroxyl ion. So when you're writing, it is magnesium chloride, which is basic. It is normally written as MgOHCl, but in the English now version, it is basic magnesium chloride. I hope hapo iko sawa. We have the same. I want to give you those ones that have similar. First of all, before we go to the rest that are, we have basic zinc chloride. We have basic. We have basic, of course, lead carbonate. We have basic calcium, copper 2 carbonate. Yeah, those ones are very important. Those ones are very, very important. So writing the inaitwa. Let me just write one for the sake of. Let me write one for the sake of understanding better. So this one is not actually magnesium hydroxide chloride or hydroxyl chloride. It is basic. Let me write this one in full. I hope you allow me. I know time is already moved, but it is better to understand a few things. So it is basic magnesium. Allow me to write magnesium in its equation, chemical formula. Magnesium, basic magnesium chloride. I write in full. Let me. So magnesium, you can write it full, but it is one basic. You don't say it is magnesium hydroxyl chloride. I hope you have understood that place, because that is what I wanted to touch on. Because sometimes mtu anakuuliza, you have written the equation as magnesium or the chemical formula as magnesium OHCl, but you are telling me that the name is basic magnesium chloride. Why? I hope you have understood that place. So it is basic, and the reason why we write it that way is we must show that it is, we want to bring in the basic property or the alkaline property of that particular salt, alkaline property. So basic property or alkaline. So if you see the word alkaline, it is the same thing. Yes, I hope everybody is okay up to that place. Please tell me you're understanding something. Maura, I think Rotich is somewhere. I'm seeing somebody else. I think, I don't know if somebody else has already, so somebody else stepped in. So I think we are communicating with you because I think Rotich is going somewhere or is on transition. Now we go to the last definition. The last definition is a salt that is normally very important. They are normally called, so before I give the other name. So these are salts that have two different cations or anions. They have two different cations. I don't know if somebody has chatted me. Let me see. If okay, it is okay. Rotich, it is okay. It is okay. I don't know. HM. I don't know. HM. You just came in. Maybe I can give you some hints. If you came in and you have not understood what I'm saying, you can just do it in the comment section, or you can just, if you unmute yourself, you can tell me. You just unaingia, and then you say something, and then I allow you to. of the class. Now, a double false. A double false is the easiest name. Most of the time, especially when you'll be in Form 3 work, there's in Form 3 work, while we'll be talking about the solubility or reaction of tests for cations and anions, I will never say double salts in that place. I'll say it what we call complex salts now. We'll be having complex salts. And these are salts that have two different. This one is saying it has two different anions or cations. So these are salts that have different ions. Different ions. In ions, now let me write this one for. I hope you know the meaning of cations and anions. So anions are negatively charged. For example, a very good example. Okay, I'll use nitatumia hiyo yenye iko chini. I'll use, for example, the easiest one, which is Trona, because Trona we are going to do it again. And then we have cations are positively charged. So cations are positive charge ions. For example, if you have two positive ions in the same source, and then we say that one is a double source. It has double charge. So she's okay. Hapo tuko sawa. So it has two ions. I'll give you this. So for example, let me just give the easiest example, which will itatupata. The one that itatupata tena mara ingine, first of all, is Trona, because it is in carbon and its compounds, which is, I think, the last topic in Form 2. So carbon and its compounds will have Trona. So I want you to see now when we're talking about two different anions, so that people can understand the difference between anions and cations. If you already know, the better. But for the sake of just, so we do it. So we have now sodium is positive. So this one is how we normally do it. Sodium is positive. Positive have been now carbonate upper. So I'll cut this place. So sodium is normally positive 1, first of all, because it belongs to group 1. Now carbonate is normally 2, negative. I'm writing actually the valence of those things. So the valence of sodium is 1. The valence of carbonates, which is I don't know if this is the class I taught previously. I don't know, I'm not very sure, but there's something else that we are going to discuss about why is the carbonate 2 negative. And then it will be determined also in Form 4. I think it is in electrochemistry, where you'll be calculating actually the oxidation numbers of what, for example, they'll say calculate the oxidation number of carbon in that case. So we will be getting those ones, or calculate the oxidation number of. So Trona actually is, this one is the full name. I'm doing Trona because it is the easiest. It's sodium carbonate dot sodium hydrogen carbonate with 2 waters. So it is very easy. Now again, I come to the second part of Trona. Hii sodium. So tumeshasema sodium is 1, positive 1. That one is okay. And then we go to hydrogen carbonate. Hydrogen carbonate. We have a name. I don't know. I'm very interested in somebody giving me the name of these things that are combined. It has a name. For example, carbonates. What is that name? And then we have I know the name, but I want to see if people can remember. What do you call those things? For example, phosphate, which is PO43 negative. Carbonate, sulfate, hydrogen carbonate. I don't know which class it is, but it is normally taught. I think it is in Form 1 or Form 2. One of those classes. So the hydrogen carbonate, you can a negative. You can do it in the comment section, but I'll give you the name. And then of course it has water. Water, of course, is neutral. Now, when you talk about different ions now, so as you can see, sodium yenye iko hapa na sodium yenye iko hapa is the same. Yes, it is the same. The sodium is sodium. So the cations actually in this case are the same. The cations are the same because it is sodium. Now, what is different now is the anions. The anions are different. So the anions in this case is We have two anions. We have the carbonate. Can somebody give me the name now of these things I'm right? Two negative, which is normally written that way. Do not mind how I've written it. Of course, when you're writing this one, it has rules. The C and the O must not come in touch. The C and O in this case are capital. Those ones are very important. You don't write it in small letters. So HCO, the reason why it looks like that is because I'm not typing it. Negative. It is 1. So we'll be doing all of those ones maybe later on now. We can do those ones later on. But this one has, so that one makes it now a double salt. Tuko sawa? I hope you have understood that one. Now, when I come to another one, that will be, we'll be getting in form, I think this one will be we'll get it in form 3 again. Hydrated, this one, the hydrated ammonium iron 2 sulfate. That one is one of the tests for ions. We normally test this one using, we normally test, is it nitrate? It's normally used to test nitrate, this one. So it is ammonium iron 2 sulfate. So allow me to just do this one. I'm doing only those ones that, so ammonium iron 2. I was saying the English version of this equation is better. For example, the answer to, if they say, give 2 examples of double source. Number 1 is Trona. So to write Trona actually is very easy. Now, to write Trona, the chemical formula for Trona is actually complicated. Now, leave alone that one. Trona could be easy because it is sodium carbonate with water. What about now if you are supposed to write the second one that we are going to touch on, which is hydrated. Now, of course, the question is hydrated ammonium iron 2 sulfate, which from the equation, of course, the equation makes it very, when you talk about it, it is very easy. But when you write it, of course, it is hydrated. So the first thing that people will think is ammonia is the one that's starting in writing the chemical formula, followed by iron, which is not the case. We'll talk about why ammonia came in the middle rather than the first part. I think that one will be handled in form 4 again. So we don't have to touch on that one. But that one is, so we have iron. So it is iron 2. So it is 2 positive. Ammonium is positive. So we have 2 positive. And then, of course, the sulfate is 2 negative. So we have 2 positive. That is why it becomes a double salt. And I'm saying the other name for double salt, we normally say we call it complex salt. And that one is normally done in another topic. If you have understood, we move on. I erase this one. Unless there is a query. Mtu ako na swali before I continue? So we actually have done 2 things. We have defined the salts, and then we have gone slightly to the salts, types of salts. Now, how do these salts dissolve? Now, in the solubility of salts, like I said, solubility of salts is water. I'll be very brief in this one, but it is very interesting. I normally like salts. I think salts in Form 2 is one of the best topics. I mean, it is the easiest topic to. HM, can you see the? I don't know. Can you see the screen? Because when you're coming in, maybe sometimes in a later shida. Maura, you admitted yourself. You wanted to say something?
Me, I can see the screen, teacher.
Okay, so we continue. Solubility of salts. Now, in solubility of salts, there's some 2 things that are very essential. We must know the solubility of salts. We have the types of salts that we are going to handle. We only handle 4 in this case. But when you talk about solubility of salts, there's something I'll touch hapo chini, which we called when they dissolve and form solutions. When they dissolve but do not form solutions, we have a different name for those ones. So it is something else that I don't know. I think it was tested either last year or last of last year because I can't. We were in 2026. I think it was tested in 2024, 2025 about hygroscopy, fluorescence, and the rest. So it was tested somewhere. So we'll talk about that, but we'll talk about that one. let us go to the solubility of salts. So we have salts. When you put something in water, of course, you have expectation. For example, before even I introduce the salt itself, for example, when you put sugar into water, you expect that itayeyuka. That is actually the dissolving is kuyeyuka. Now, when you put sand in water, does it dissolve? Well, those are the kinds of those are things that does it dissolve? No, it doesn't. Uh, Glucose in water, it dissolves. You put what else does you put, for example, iron filings. Zile za when you uh, uh, the Kiswahili word is inatoka. When you're sharpening, let me use that. When you're sharpening your panga, your kisu, na hiyo filings ingie kwa maji, does it dissolve? They do not dissolve. Actually, so solubility of salts, we do not define it in this class. In Form 4, I'll tell you the meaning of solubility, and it is still in salt. So when we'll be in Form 4, we'll say solubility of a salt is the amount that dissolves in saturation in 100 grams of water. We talk about 100 grams of water. That's what I was telling you previously. So we'll be talking about 100 grams of water. So we don't even have to touch on that one now. So in solubility of salt, we normally say when you put water, you put in an experiment. If we are in the lab now, I'll have placed two, I'll place maybe 3 test tubes or boiling tubes. Let us use test tube because it is the smaller one. We use test tube, naweka 2 centimeters tube each, and then I put a spatula full of different salts in the lab, and then I test the one that we dissolve. So add another one will form clear solution. It will dissolve and form a clear solution. Others will form a suspension, or what we normally it is. I don't know why students normally do this. I don't know if it started from, the problem with teachers is sometimes we say white PPT. Now, so when you're in an exam room, you sometimes write it forms a white precipitate, white PPT, but you write now it forms a white PPT, not the white precipitate. Of course, white PPT could be. We are talking about PPT means a lot of things. It means computer sometimes when you're using PPT to teach or something. So you must write in for. Or we say now when it forms a white precipitate, if I place sodium chloride in a form clear solution, I place barium sulfate, it forms a white suspension of a white precipitate. We say the one that forms a clear solution is soluble. The one that form a white precipitate is insoluble. Now, these ones are normal. I like the way these ones have been arranged. I normally say when I am doing revision for my students, especially the Form 4, I normally advise the Form 4 to start this way. I'll just show you how it normally starts. In the notes, of course, it could be misarranged, yeah. But when we are writing, we normally start with those ones that are soluble because it is very easy. All salts are soluble except carbonate. All carbonates are insoluble except a few. So we start with the soluble or the insoluble, depending on you. But for the sake of this one, let us just do it this way. So we can start with this one. There's something that we spoke about when Ukoju, I think HM was not in. I said potassium, sodium, and ammonium salts, they have a special case. They have a special case. So the special case is in the north, NB. Uko chini, but there's no problem. So we say all carbonates are insoluble. All of them are insoluble, except the 3 now that we talked about that are special case. Potassium, sodium, and ammonium. Now, there is a problem. In these carbonates, we have the insoluble ones, and so all of them are insoluble. So sometimes they tell you to give examples of insoluble carbonates. Sometimes watu wanaandika aluminium carbonate or iron carbonate, and those ones very important. Wacha tu niandika hapa aluminium, please. Aki msisahau hii. You can forget everything else. So this one, I don't even know if the formula would have been like this. So aluminium carbonate and iron. And iron, sorry. And iron. I don't know if you can hear me still. Can you hear me? Very well. Iron 2, iron 3. Let me just do iron 2. We have two ions. Tafadhali msisahau hii kabisa. If you forget everything that I mentioned today, you'll forget this. But hopefully I know you will remember. So the iron carbonate, iron 2 carbonate, iron 3 carbonate, aluminum carbonate, hizi vitu, they do not exist. Aziko, they have never been found. So they are not there. So all carbonates are soluble. All carbonates are insoluble except the three of them, which is, I've said we have a special case for potassium, sodium, and ammonium. So all of them are insoluble. And then we have two zenye haziko, na ndio hizo nimeweka hapo juu. Aluminium na iron. Iko sawa. Now, I can wrap that one. But I just wanted to tell you that they do not exist because it is not in the notes. So please, very important. So we only deal with phosphorus in this case. But I'm saying ukiendelea, we'll be talking about others. When you continue with, if you continue with this, you will find others. Now, number 2 is the chloride. All chlorides again. Now, the remaining are soluble except a few. So all chlorides are soluble except silver and lead. I can attest for those ones who, Maura, you will tell me, in the practical of last year, you were testing chloride. But I was there. So you were testing chloride. Did you test chloride ions? Where you added something, and then you added lead ions, you added HCl, and then you were told to warm, and then it dissolved. Did you do that in the practical?
Yes, we did that, teacher.
Yes. So it was this. So it was there in the practical. So all chlorides are soluble except silver and lead. Of course, lead chloride has a special case. It is soluble in hot water or warm. So they'll tell you warm the mixture. If it dissolves, you say now it is chloride ions present or lead ions present, depending on the nature of the question. But it was there in the practical. So I don't know what will be there. So all chlorides are soluble except the two of them, which is silver and lead. And lead, of course, chloride is soluble in warm water. As you continue warming the water, ikiendelea kuwa joto, it will dissolve. Number 3, which is nitrates. All nitrates are soluble. All of them that exist. All nitrates that exist are soluble. All of them, you can name now the nitrates that you know. Starting from, of course, now you don't mention, when you want to talk about this, you munawacha potassium, sodium, and ammonium, because all of the salts are soluble, whether it is a carbonate, whether it is, so munawachana na hizo. All others now, all the nitrates, you can mention calcium, you can mention zinc, and the rest, lead, all of them are soluble. Number 4. So this one is very easy to remember, but I'll still share these notes. I think I'll share the notes for the sake of follow up. I'll still share some of the questions. I can give questions because I have not. I think I have questions on most of the questions in these most of the topics. So I'll share even those ones that you have been taught previously. Now, so all sulfates are soluble except barium and lead. I don't know. It's people sometimes say lead, lead is the same thing. So all sulfates are soluble except barium sulfate and lead sulfate. Calcium sulfate is normally confused. I normally tell students it is confused. It is slightly soluble. It is slightly soluble. But barium sulfate, in fact, there is something special about barium sulfate. I hope I'll be the one who will be taking you in Form 3 about sulfur and its compounds. Barium sulfate is normally used to test for sulfates and sulfides, barium. So it gives a special outcome for sulfates and sulfides. So we'll talk about that one later. So all sulfates are soluble. So you can see all of these ones are soluble, except carbonates, which are insoluble, except of course the special case, which is in NB now. So we have NB, which is the north. You note that all potassium, there is potassium, sodium, and ammonium salts are soluble in water. They all of them, whether you have ammonium chloride, ammonium sulfate, ammonium nitrate, ammonium carbonate, they are soluble. The same case applies to potassium, sodium, and rest. And of course, kumbe iko hapa chini aluminium and iron carbonates hazijapatikana. Maybe you study other way, you come up with that one. I don't know. Hazijapatikana. As of today, it doesn't exist. And I'm saying in chemistry, everything is possible. So other things are still being developed. So we continue. So I hope you have understood. And maneno ya solubility, it is so dangerous, so dangerous. So this one is a summary. This is a summary. Soluble salts. So we have been given hapa umepewa. So you have been given the insoluble salts you have been given on the other side. This one is a very good table. This one is a table that you use when you're going to the exam room na umeshikika. So you're in a hurry, you want to just peruse through. So even though it will help you, you don't read a lot. You say soluble salts, all nitrates, all sulfates, except all sulfides. Now, that is why I was saying barium is normally used to test for sulfides and sulfates in DOE, if you can see. So this one has included sulfides, we have chlorides, we have phosphates. As you can see, now I'm saying the only one that we deal with in Form 2 are the 4. But we have other salts. That is what I said. We have other salts. We have hydrogen carbonates, which is a salt, hydrogen sulfates, which is also a salt. All of them are soluble. And then, of course, the insoluble salt is all carbonates except. You see the arrow that has changed? I want you to see this arrow that has changed direction. So it is very important so that you don't get confused a little bit. So we have these. All carbonates are insoluble. From that line, insoluble salt. Each line pure is soluble salt. So all of them are. So it is very important for you to capture that one. This one is just a summary. So I'm saying we have a lot of salts. We have a lot of salts. In fact, this drawing or this diagram does not actually exhaust all of the salts that we have. So it is very important for you to. So nimesema this table is very useful when you're in a rush. For example, umeambiwa you are having a meeting and then you have an exam maybe in the afternoon, but you have the chemistry exam and you have a meeting, your job in the morning, and you are aware that you're supposed to go through the solubility. This table will help you a lot. Yes, unless there's a query. If you have a question, you tell me. If you have a question, you tell me. If you have a question, you tell me before I go to something else. Solubility of bases in water. So bases actually are salts. Bases are salts. Bases are normally categorized as salts, but basic salts now. So tulikuwa tumeongelea huko juu. Yeah, those things that have OH group. So we have those ones that are basic salts, but bases mainly anomaly. So we have soluble bases are also known. So there's a place I had mentioned of alkaline solution. I don't know if you remember pale nilikuwa nimesema alkaline. There's a place I mentioned alkaline solution. So basic solutions are also called alkalis or alkaline. So those ones, they normally come in there. So we have alkaline. So mara mingi pia ukisikia mtu akisema, maybe sometimes the teacher could be talking very fast na usikia amesema this one is acidic and this one is alkaline. So maybe angesema tu basic. So basic alkalis and alkaline. Basic alkalis, alkaline, they have the same meaning. We are talking about the OH group. And when you talk about OH group, you never forget about, I don't know if you are told about oxides. We have what you call amphoteric oxide. I don't know. I think it is in this class also. But we'll talk about that on another time. So oxides, we have oxides and hydroxides. Some oxides are soluble, but most of the oxides are insoluble. Most of them are they are insoluble, and most of them are black. Most of them, I've not said all of them are black. Most of them are, but some are soluble. So, for example, of course, we remember. I want you. The reason why we use this one, sodium and potassium, is because we are aware. Remember, we are aware that all of the salts of sodium, potassium, and ammonium are soluble. That is why you have seen the example that we have given here. The first example is sodium hydroxide because sodium is soluble. So we might use something else, but it could not be soluble. And we are looking for what? Alkaline solution or alkaline solution or alkali. So sodium hydroxide and ammonia and ammonia. Anyway, this is ammonia. Potassium hydroxide are soluble, and when they dissolve, they form what? A basic solution or an alkaline solution. That is what I'm saying. Now, oxide and hydroxide of group 2 elements are slightly soluble. Are you seeing now the solubility is reducing of these things? That is what I'm saying. Oxide and hydroxide, which are will be. I think this one will be also mentioned in another topic. It must be mentioned in another topic. So, oxides and hydroxides of group 2 elements are slightly soluble. So, as you move across the period, the solubility will be decreasing. Now, let us see. Hydroxides and oxides of the rest of the elements are insoluble. That means you have moved zinc. Aluminium is in group 3. As you move, you find that they do not dissolve. Now, of course, ammonium oxide does not exist, but we have ammonium hydroxide, which is normally used in test for cations. We'll talk about that one in form 3. It is repeated in salts in form 4. Yeah, it is repeated twice. We do it. Yeah, we do it twice. We do it twice. I don't know if it is 3 times, but I'm very sure of the 2 times. Iko sawa mpaka hapo? So these ones, let me just go to the summary because ammonium oxide does not exist, but the summary is this now. And of course, effect on the litmus paper. By the way, have you ever been told on the effect of the litmus paper? I don't know if you were told on effect of the litmus paper. Maura, have you ever been told on how the litmus paper is affected by either an acidic or a basic alkaline solution? Have you ever been told?
Yes.
Okay, so I just have to go through this. I don't know if I'm moving too fast for some of you. If I'm moving too fast, you say, yeah?
You're okay. The pace is okay.
Okay, okay. I didn't want to. Okay, no problem. So, summary of test of solubility of bases. So we have cation. Now, remember, huko juu nilikuwa nimesema cation and anion. Cations are positively charged. You remember pale tusema positively charged. So if I wanted to, cation will be this cation. In this case, let me just write for the sake of because it will be used somewhere. Cation of potassium will be, you find that it is written K. Don't mind this one, but write very well. K positive. We have Na positive. Ukiona kitu imeandikwa hivyo, it is the cation. Ukiona imeandikwa hivi, I don't know, let me write it on top. You can see my pen. This one. Let me write a simple one. Chloride. Hii ni anion. Yenye ni negative, anion. Yenye ni positive, tunaita cation. That is why I was saying, test for cations will be using sodium hydroxide. You will find we'll be using sodium hydroxide and potassium. No, not potassium, sodium hydroxide and ammonium hydroxide, not potassium. So we'll be testing test for cations. I think I'm saying we'll do it in form 3 and form 4. So in form 4, in fact, in form 4, it is in the next topic, which will be acids, bases, and salts. So when you'll be doing that one, you will touch on that one. So another one, we have calcium. It is very important for you to know the valence. So calcium inakwanga 2 positive. Mark that one. Magnesium also is 2 positive. So you write Mg. M is capital, G is small. 2 positive. Iko huko juu valence. Those ones are, or we call it the oxidation numbers. The oxidation numbers. It is normally calculated. Or we have rules that are followed. I think it is in the second topic or the third topic in form 4. Zinc again, the same way. Zinc is 2 positive. So anyway, those ones are times. Aluminium is 3 positive. Copper is 2 positive. So those ones are, so you can see the solubility. When they dissolve, does it affect the litmus paper? So it will affect the red litmus paper. Bases affect red litmus paper. Acids affect the blue litmus paper. I'll repeat that one. Acids affect the red litmus paper. No, acids affect the blue litmus paper. We are talking about bases, yeah. So we start with the one that we are talking. Bases affect the red litmus paper na inaichange kuwa nini? Blue. When you talk about acids, acids will turn the blue litmus paper red. That is very important. And we normally use litmus paper to test for a lot of things. Now, actually, the only thing that I cannot give you a score if you wrote for me is telling me that water is neutral, so it doesn't have any effect on the litmus paper. Otherwise, water will not taste water that way. Actually, somebody will give me the how we taste water. Maybe before the end of the lesson, somebody to tell us how we taste water, how we make sure that this one is water. There are two methods of testing water. The best methods actually are two. Of course, the other one it is not a chemical one. Chemistry is chemical, inaenda chemical. So it's not a chemical one, but we we can give leniency, but it is not the correct one. But we have two major preparation of sauce. So you must know how these ones are preparation of sauce. Now, when how we normally teach this topic, myself, I don't normally teach this topic the way it is normally taught in the textbook. Reason is most of my students are low achievers. I can say low achievers. They are not really very bright. I have very few bright students. So if I taught the class this way, obtaining crystals of copper 2 sulfate from a solution of copper 2, that one I normally quote what we did in form 1. There's something that we did in form 1 where you are separating a solution. You're making crystals. I think you're making crystals. Or separation of two things where you are boiling, utoe maji, and then it remains. I normally quote that one. So that, and I don't prepare, actually, I don't prepare the salt, the specific salt. For example, in this case, we are preparing a specific salt. Because if the question comes differently, ikikuja differently, they will answer using now ile yenye tulifanya class. I don't know if you have ever encountered even your children doing that. So they quote, they do exactly what was taught, and they don't even want to read the question. They say we are preparing the soluble one this way, which is normally quite sad. But anyway, for our case, we can just know how this one is done. So this one is the procedure. Now, in chemistry, you are very lucky. In chemistry, students are very lucky. The only time that students were told to write the procedure, it has been a while. Imekuwa kitambo sana. I think it was 2000 what. It has been a while since students were told to write the procedure. The only time you are told to write the procedure is when you are doing an exam, and it is not the practical one. It is the paper 1 or paper 2. When you're actually doing with the preparation of something, they tell you starting from, yeah, and it is still source. Starting from this place, tell us, starting, of course, you're given, for example, sodium sulfate and lead, or we are given sodium carbonate and lead, nitrate, and you're told, starting from these two, prepare lead carbonate or lead sulfate, that one. So anyway, so the procedure, so 10 centimeters of, you put it in an evaporating dish. Of course, I'm very sure that most of you know the evaporating dish. Ni kitu kama which example can I give? Kuna hizi masahani zenye ziko flat. Yeah, I don't know, I only know one company of masahani which is Luminac. Kuna hizo Luminac flat kabisa. Now, the evaporating dish in the lab is something like that, but smaller. Or I can use, is it a concave? A concave lens. If you have seen a lens, I know you have seen a lens because you are doing biology. Most of you are doing biology. So lens inakwanga yenye imeingia ndani hivi curved kidogo, normally evaporating dish. Sometimes you're given in the lab when you're doing practical. So I normally mention these ones in the theory because some students might not really go to the lab. So ili wajue ni nini. So evaporating dish utapata kitu kama sahani but very small and it is clear. It is clear. So that is an evaporating dish. And then that one is the procedure. I don't want to go into okay. I thought somebody was in. So to obtain larger crystal is covered with perforated paper. The crystal. So observations is very important. The observation now is what they normally ask. What will be the observation? I hope you have. Maura, are you okay with me going that way? You just have to check the procedure and then I continue.
Yeah.
Yeah, because I'm
Yeah,
interested
okay.
in. Yeah, because I'm really interested in the observation. The observation is where the students normally get everything wrong. I don't know. Now, observation, I want to advise you. Now, the cases of last year, the paper one and paper two, I don't know, it could be confusing. It was not really good. It was not really bad either. Sure, come my the other year. I think 2024, the paper was, yeah, for students, of course. Now, last year's paper, the paper one and paper two was likely ilikuwa tu hapo 50-50, depending on how you studied. The paper three came of last year. Somebody could easily score 40. Ni uongo mano. Ukweli ama uongo Mwauri? The chemistry paper three. Yeah, that chemistry
Paper
paper
three.
3 was very easy. It was too easy actually. And I think people failed because it was too easy. When the exam is slightly confusing, students tend to pass because they have the experience what you call the critical thinking now that time. When it is easy, the critical thinking switch equal off. So they are like, this one is the other one that we were told. Yeah, that is what happened in paper. I think in paper three, it was too easy. It was too easy. Like a student could have completed that paper within 1 hour, and so it was very. It was That is so. What I normally advise most of the times, what I tell my students is your observation is correct unless you have problem with your eyes. Your observation is correct. I will give you an example very quickly before I just conclude this observation and explanation. I had 3 students who are doing physics in my school. Now, the 2 students were the brightest in the school. Like they could have scored easily an A star. Now, the 3rd student was a student who was what can I say? I was requesting him to do physics so that he can boost himself. He was an automatically E student. We normally know students in class. So he was an absentee. He was a student who opens schools after 3 weeks, and then he stays in school for 3 weeks in the whole term 1. and then disappears for the rest. Yeah, and it happened since Form 1. It is that student since so I forced him during the practical physics practical itself. He was the only one who made the correct observation. He was the only one who made the correct observation and did the correct graph. The rest, the brighter ones, I don't know if it was confidence or what. Actually, they did the wrong thing. So what I'm saying now is, please, when you are doing your practical, your answer is correct. Whatever you observe is correct unless you have problem with your eyes. If you are colorblind, I think now that is where you can now ask somebody, how is this one? What is the color? And I don't think Africans were colorblind because that one is actually a disease and it can be corrected. So unless you have a problem with your eyes, and that is being colorblind, please, your answer is correct as far as I'm aware and as far as you are aware at that time. Anyway, so the observations and explanation, I was doing the observation and explanation for you. So when you must find out. So the glass rod is over deep to find out, but that one is not the observation. That one is only what you are doing. You dip to find out whether the solution can form crystals, and of course, ukidip na utoe, ikikool, you will find that inakuwa white, inakuwa na white particles on top, but the road was clear ukiweka, or it was clean. Now, so if it is ready, now you say now this solution is saturated. Now saturation, let me just explain saturation using homemade things. Kuna time unaweka shuge. Let me just use that one. There's a time unaweka sukari kwa chai. Na ukiweka sukari kwa chai, the normal cup, I don't know, we used to call it number 7. I don't know, number 7, number saba. The number saba, ile ya nyumbani kabisa, the metal one. The metal, let me use the metal one because I think most of us grew up in Reserve. So the metal one, ukiweka 3 spoons of sugar, na ukoroge, all the sugar will dissolve eventually, yeah? Ukiweka, for example, 20 teaspoons, will it dissolve? So it will not dissolve. Kuna pali ikifika I dissolve tena. When ikifika that place yenye I dissolve tena, now we say that solution is saturated. A solution which cannot take any more solid, because solid is the solid, solvent is the liquid. And then when the solvent and the solid are combined, it forms solution. So when it cannot dissolve, now we say that one is saturated. I hope you have understood the meaning of saturation. Basically, I normally say it is easier to explain using things that you can see, that you can actually do practice on. Because you normally, I know most of you, munaeka chai. If you don't take sugar, you use salt, or you don't use salt, there's something you do at home. I mean, it cannot dissolve anymore. So when that place now, when it has reached saturation, that means it cannot dissolve any other. It may dissolve paka, it may jump. It is saturated. The crystal can be formed. And then, of course, now the crystallization. Now, I don't know. Students normally confuse fractional and crystallization. Yeah, the crystallization process and the fractional one is slightly different. Slightly, I don't know why they confuse. They are normally different. I'm only quoting what my students normally have as a problem. So they normally get confused. So when the crystals are formed, that process is called crystallization. So it is a process of obtaining crystals from a saturated solution. Yeah. And after you have obtained crystals, there are two methods. There are two methods. There are normally two methods of separating, of drying crystals. I will talk about that one later on. But I think you have also been told in another class. So I think you have also been told in another class how that one is done. But crystals NB, evaporation, not done to dryness. So that one, evaporation actually does not bring dryness. That is why you will find in the procedure that they normally say dry using filter papers. you will find filter papers, and filter papers is normally more effective. Sijui kama tuko sawa. I don't know if you're understanding what I'm saying. I know I'm moving a little bit faster because I wanted to. There's a place nilikuwa nataka kufika tu. I don't know if this one is a full class because while tutafika, I'll come and continue from there, or the next teacher will continue from that place. So when you form crystals, we have now what we call water of crystallization. When you're forming crystal, when we talk about hygroscopy, how solutions are formed, or how solutions are not formed by salts, we'll be talking about water of crystallization. So water is the fixed amount incorporated within the crystal. For example, we normally say copper 2 sulfate is hydrated. It has a certain amount of water inside, but now you cannot remove that water, and when you add the water still remains inside. It is normally called the water of crystallization. The water of crystallization, actually, something can be a solid. For example, copper 2 sulfate is normally solid, but it has inside water of crystallization. It is incorporated to itself. Yeah. So this is a fixed amount of water incorporated within the crystal structure of the salt. Yani kwa jina, for example, when you are writing the name of that salt, you must indicate the water of crystallization. We have sodium carbonate, it has 10. So you mustn't, it is a solid, but it has water inside, and that water cannot be removed. Sijui kama tuko sawa? Yes. I don't know if you're okay up to that place. So I want you to give, let me just give you these ones. I know the most important part that I'm supposed to do is a preparation of sauce. We are supposed to prepare sauce, by the way. It is, I don't, that preparation of sauce, I want everybody to be keen when you're preparing sauce. We have soluble, insoluble sauce. Those ones have special cases. We have different methods of preparing sauce. So we'll talk about that one another time. Ndio hii sasa NB. Are you seeing what I was talking about hapo juu? I said the best way of drying is not actually evaporation. Sio ile ya kuanika nje. Yeah, I know some of us are advised to anika the salts. Crystals aren't dry by heating or cook. Of course, heating is using the. So when you heat now, you drive out the water of crystallization. And this one requires very high temperatures, by the way, to remove the water of crystallization. So what we do, and when you get an anhydrous copper 2 sulfate, it will have a different color. But hydrated copper 2 sulfate has a blue color. So copper ions are normally blue. So we do not normally dry using by heating. That is why I'm saying in the lab, you normally find some round papers, makaratasi fulani round tu zimekaa hapo, umewekewa kwa lab. Those ones actually are the filter papers. Kuna venye inakunjwa. I think I'll share a video of how to kunja how to fold that. You just, if it is a circle, for example, I don't know, I think I can share the videos. I can share the video later on in the group. Let me look for that video. I think I had the video of folding the filter paper and how to use the filter paper. So you dry using the filter paper because the filter paper, actually, you get the solid, but you still don't interfere with the chemical formula. Now, so these ones actually examples of hydrated salts we have. Now, we normally say copper 2 sulfate. Hydrated, we do not actually say copper 2 sulfate penta, that means 5 exact. We do not normally talk about that one. We normally only say hydrated iron 2 sulfate. Hydrated, we don't normally mention the number of moles of the water. Atusemangi the number of moles of the water. But as you can see, this one now has been mentioned. Ama nyinyi I don't know if you have, nyinyi mnaambiwa kwa shule or where you are, copper 2 sulfate pentahydrate. Have you ever been told of that one? They normally say hydrated copper 2 sulfate. We assume that you are supposed to know the amount of waters that are in the so that one is the chemical formula. Iko sawa mpaka hapo. how you normally told in for example, when you're when you're doing practical the other years that you did, were you told it is copper 2 sulfate, or is it hydrated copper 2 sulfate or copper 2 sulfate pentahydrate?
Hydrated copper 2 sulfate.
Yeah, yes, we normally say hydrated, but it is very important for you to know the amount of waters that it is there. In fact, in the moles, I think it is moles where you normally calculate the amount of water. Actually calculating mpaka upate 5 was the 10, so it is normally calculated. Unless there's a query, is there a question? Anybody with a question before? And there's something I had asked, by the way, Ukoju. There's something I had asked Ukoju about. I didn't want to say the name first. I wanted people to identify. We have those things that have more than one, what can I say, elements, but they cannot be subdivided. For example, carbonates. I was talking about the carbonates. For example, I'll tell you what their name, but I want people to try. We have these things. Inaitwaje carbonates zenye zinakuanga hivi. We have carbonates, we have hydrogen. Hydrogen carbonates. Hizi vitu
Radicals.
zinaitwaje? Yeah.
Radicals.
Yeah, I wanted people, yeah, they are called radicals. So radicals, they actually cannot be separated, but they are very essential. So they are called radicals. I think it is in Form 2. We'll mention it in Form 2 again. There's a place, radicals. So radicals, we even have a law for radicals when we are talking about, when we'll be dealing with oxidation numbers. Oxidation numbers for radicals. We actually have it. I have one for them. So preparation for salt. I have very few minutes. I have very few minutes. I don't know if I'll start preparation, but we'll do something else. So preparation of sauce. Actually, if I knew that mulikuwa mnajua hiyo solubility of salts and the rest, this one is the place that is very, very dangerous. And this one requires people to be very keen. I don't know who will teach this preparation, but preparation of salts is very dangerous. But let us just go to PT to a few. We can just go to a few. Preparation of salts. We have most important thing about preparation of salts is to identify. That is why the person who made the topics actually was very clever. I think this one is very high IQ. Now, when you prepare salt, the first thing you are supposed to know is it soluble or insoluble? Ukijua solubility of that salt, it will be very easy to prepare for you. Now, number one is preparation of soluble salts. So soluble salts have very many methods of preparing. So and it is easier. Now I want to say this one. Now, yeah, quote me anywhere. It is easier to prepare soluble salts than an insoluble salt, because sometimes when you mix things, it could form a coating. For example, if you are preparing lead sulfate, now mix sulfuric acid and lead, that process will not continue actually, so it will stop immediately. So the procedure of preparing insoluble salts will be longer than preparing the soluble salts. So we have very many methods of preparing soluble salts. Number one is direct synthesis. Direct synthesis is normally used when to prepare sodium chloride. That one is done in, I think it is also done in Form 1 when you're writing the equation. We have, so I started from number E, yeah, but let us go to A. So action of dilute acids on metal, carbonates or hydrogen carbonates. That means you do the mix directly. Acids and the carbonates or the hydrogen carbonates. It will give you, it will form three things. You'll have the salt. We'll have, of course, the water, because it is an acid and something that has basic nature, or something that has some basis. So it will be something of a neutralization. But because of the carbonate and hydrogen carbonate, it will form CO2. So that one. Number B is action of. Now I'm just explaining it very fast because we'll do it actually. as a subtopic. Iko sawa? So there's no problem. Action of dilute acids on metal. This one again, you are mixing directly. I'm bringing HCl and then I bring sodium and then I mix them. It will form sodium and sodium salt, which is sodium chloride and hydrogen gas. This one is what we do in Form 1. It is a preparation of hydrogen in hydrogen and water in hydrogen. Is it hydrogen and water? That is the last topic in Form 1. It is actually done. Action of dilute acid again on an insoluble base. Insoluble base, we have a lot of them. We have insoluble base. We talked about insoluble bases. You remember huko juu? We have calcium oxide. You can even do that one. Calcium oxide plus the dilute acid, you'll get. Actually, you will get it. That one is number 3. Number 4, dilute acid with a alkali or a base. This one now is the neutralization. I just write this one. I'll write for you this one as neutral. This one now, another name for this one is neutralization reaction. Ile ya kwanza yenye tulifanya when you are dealing with sodium hydroxide and sulfuric acid. So in neutralization, the one that I mentioned, huko juu. And then direct synthesis is actually combining things directly. For example, we are bringing sodium and chlorine and then form sodium chloride. So those ones are some of the processes of preparing. I don't know if time will allow us. I don't want to interfere with this one. Preparation of sauce. I don't. We only have 5 minutes. I don't know. Do you think we should interfere with this one? Because I'm finding it. If I do, I want to complete this on the same day. So unless you have a query in the things that we have done, now is the time, or something else that you did previously. Let us do those questions as I write this one as neutralization. So that nisianze hii na tuache katikati because I know people are busy. You have another class maybe later on. But I hope I'll be the one that handle this one this week. When you have chemistry, I can request so that I complete this one, if it will be okay with you. That is, if it will be okay with you. Alternatively, somebody else. You have very many. I think we have many teachers that can handle these topics. Neutralization. So neutralization reaction is one of the best method. Actually, if I was to teach this one for students who are a little bit slow learners, or we don't normally call them slow learners, time takers. They are called time takers. I'll start with the simplest one, which is direct synthesis, which I actually have done with direct synthesis because nimesema una combine things directly. For example, sodium and chlorine, and then I go to the neutralization reaction because actually you already know the neutralization reaction from previous interactions with chemistry in form 1. So unless there's a query, I'm waiting for a question. You can do the question on the wall, or you can ask because there are very few.
Teacher,
In
test
the
for
meantime,
water.
yes. I had a question on test for water. I don't know. Yes, please now. I want people to tell me test for water. How do you test water? No, open forum. Test for water. We have 2 methods of testing water. And actually, they are related. They are really very good. They are very related, such that you will never forget. Somebody to give us. And I have not heard some voice of somebody. I don't know. Rotich, are you okay now? Can you speak? HM, I don't know the full name. HM, can you say a word? It is okay. As I give you the test for water. I can even give you that one as an assignment, but I'll give you what to do. I'll give you the chemical that is used to test, and then you give me the color changes that will happen. See, that one is better than me giving you the answer actually. I think this one you can even ask.
Maybe I can try one. I only know for anhydrous copper 2 sulfate.
Yes, you have anhydrous copper 2
sulfate.
Yes, that is
I
one.
Don't know the other one.
Now, what is the color change that occurs now in copper 2 sulfate?
Blue.
It changes from what color to what color? It changes blue.
White to blue.
Yeah, it is white to blue. So it is anhydrous copper 2 sulfate is white. When you add water, it becomes blue. Because power, that is number one. Number two, we have now what we call anhydrous cobalt. Anhydrous cobalt, let me just, actually it is anhydrous cobalt, this one.
Oh, cobalt 2 chloride.
Yes, now, I'm not going to give you now the color. You go and look for the color. But one of the colors is iko kwa ile iko kwa ya copper 2. So I normally say it is the same thing. The color, one of the colors is in the other one.
I think
Cobalt.
if it's cobalt, it turns from blue to pink.
Yeah. So actually, those ones are the major ones because it is chemistry. So we are dealing with chemistry. So chemistry actually we are talking about we are actually talking about testing something using a chemical. That's why those ones are the first priority. Now sometimes in physics, now when you talk about physics, now I don't know, we normally say we can borrow because I teach physics. We normally borrow. We normally borrow the reason why the boiling point is not used as a method of testing if something is water. It's because we have the anomalous. For those who are doing physics, anomalous expansion of water. So we scrap that out because water behaves in a different way. Sometimes at a certain temperature, it is behaving in a certain way. And then remember, again, another factor that really affects not using a boiling point, because most of the students normally write for you, boiling point of water is 100. Yeah, we know it is 100. But that one is not actually the correct. Another reason is because of the impurities, effects of impurity. I can give you that one as your assignment again. Effects of impurity in the boiling point and melting point. So we have impurities. Some water could be impure. How do you know that the water that you're using is not pure or is not dirty? So the reason why now maneno ya boiling becomes scrubbed out is because of that. Yeah. So, but the main ones you should know, please know. You can even go and write down somewhere, but I'll still be mentioning them. I normally do this one because students normally tend to confuse the news maneno ya boiling point, which is wrong. Please not use maneno ya boiling point. Use anhydrous copper 2 sulfate or anhydrous cobalt 2 chloride, which is the. And this one I don't know. I'll check if I have something else, a video, and then we can watch together. Unless there's a query, unless there's a question. I don't know. Have you understood something? Because I didn't want to start for 10 minutes. Preparation of thoughts could be very dangerous. I don't want to go and touch on things, but these ones are the methods. So when we meet next, or when you meet with the next teacher, they'll continue with the. Please, maybe a request. Maybe if we have a class next time, we can start a little bit. I was in by the way by around 7:50, and we started around 8:20, 8:30. So please, let us keep time. I know we are very busy, but if you are busy, we can push the class. You can say, you can just write in the suggestion that we push the class for maybe another 30 minutes so that we can do something else. Let me tell. Unless there is a query, I don't know. I think we can end it there for today. When we meet next, we do preparation of thoughts. Unless there's a query, Maura, you okay?
Very much okay, teacher. Thank you so much.
Yeah, yeah. Thank you, HM. I don't know if we can hear your voice, or if you're okay. Okay, understood. Roti, you okay for today? We meet next time, but we'll start from where we left today. Yes, you have a very beautiful weekend. Until next time. Thank you
Have a lovely
and bye
one
bye.
too. Okay, bye.